Welcome back to class. Today's lecture is going to be the below oh man. Well, welcome back to class. Today's lecture is going to be below grade dewatering systems. The only place quiet in the house that I could find to record this lecture was in my daughter's bedroom. Everywhere else is too noisy. So sorry if it's you can hear the family having a good time. But that's the way it is today. And no video because you don't need to see my daughter's walls decorated. But the topic today is sort of, I don't know that it's really discussed well in the book for the class. I wanted to cover it, and this was one of the first challenges that I had as my first part of the management. And let me show a little bit of the first project that I was on. So the first project I was on that was this building right here, and it's the Bear River Migratory Bird Refuge. And so this education center, I should say, this pond at the time it's been deepened, but it was there, mostly there. And so we're building this building right on the marsh, or right on the I don't know what to call it, marsh, I guess, the wetlands. And so that has a full foundation underneath it, meaning a full basement. It's I think the basement's the foundation walls are 8 feet tall, big mat footing down there. So imagine having to deal with this water and the foundation at the same time. And there was a dewatering plan, and we'll talk a little bit more about that. And it worked great. Um, so that's sort of the introduction. My first project that I think I was titled Assistant Superintendent, and learned all about dewatering systems and what happens when the pumps go out, or what happens when we switch over to the main system. So let's jump into the PowerPoint, have some drawings to look at as well, and we'll look at it from both the residential and the commercial standpoint. So let's go jump into that. So first, with the residential side, the International Residential Code requires drains. And so I'm going to read this a little bit here. Drains shall be provided around concrete or masonry foundations that retain earth and enclose habitable or usable spaces located below grade. So drainage tiles, gravel or crushed stone drains, perforated pipe, or other approved systems or materials shall be installed at or below the top of footing or below the bottom of the slab and discharged by gravity or mechanical means to an approved drainage system. All right, that's a fair amount to read in a PowerPoint, but I want to dissect a little bit of this. So we've got a basement, and in this graphic here, we've got basement wall, got a slab on grade here, right? So slab on, we've got a footing down here. So this is definitely a basement wall with the slab. So usable space, habitable or usable space for sure, right? Um, so it requires drainage tile, gravel, or crushed stone. And we can go look at this drawing real quick. Let's do that so you can see it better. All right. So in this detail, we've got the waterproofing on the wall, and to me, it looks like we've got some sort of mastic, probably is what we're going to be putting on, and then a drain board. So there's going to be a way for water that gets next to the foundation up here to travel down the drain board. And the drain board is, if you think of the bubble wrap that you get with packaging, it's a hard plastic version of the bubble wrap, but not so many bubbles, and so there's spaces in between the bubbles, and there's like filter on each side, and so water goes through the filter fabric on one face, and then the little bubbles create a path between the drainage part or the backing and the filter that's on the front. Allows the water to come through down. So let's look at the rest. They've got a 6 mil vapor barrier underneath the slab. That's trying to make so that we don't get vapor coming up through the slab. We're going to ignore that part. Oh, no, we can't. Sorry. Expanding concrete joint water stop. So they've got a lot of times they'll use a bentonite clay water stop. Looks like that to me right here. So bentonite clay is highly expansive. It comes in just these big sticky rolls and about ½ inch wide and ½ inch tall or so, and you put that along the foundation. I'm sorry, I said that wrong. It goes on top of the footing, and as you place the foundation uh, concrete gets cast all over the top of this, and then if any water does come in this way, it will expand and get into any kind of voids in the concrete and act as a water stop is what it's called. But and then we've got this 1 inch high minimum rigid non biodegradable cant with fluid applied waterproofing at the. So they're just doing. You could do that on a lot of things. Anything that's non-rigid, non-biodegradable, or rigid and non-biodegradable. Cant is just a way of like saying you come out of the corner with something that's at an angle, and then being able to get some waterproofing over the top of it. So waterproofing all the way down to the footing is what they want. Drainage board. And then what's this right here? We've got the 4-inch perforated drain tile and free draining gravel wrapped in a filter fabric. So we've got a perforated drain. For this case, I'm going to call it a pipe instead of a tile. I'm not so sure why the word tile is used. I've never understood that. Maybe if people know, tell me in the comments or whatever. So that's our perforated drain pipe, and it's going around the foundation. And then this area here, the green area, that's all gravel. And then we've got a filter fabric all around this. So try and keep this in your mind, and let's look at the code again, exactly what it said. Go back to PowerPoint. Perforated pipe installed at or below the top of the footing. So it's definitely at or below it. This is below. Or below the bottom of the slab. So if we raise this slab up and this was like uh, you could have this pipe be up here if this footing dropped really deep. There's the point. And the discharge by gravity or mechanical means into an approved drainage system. So what's the code mean there? So you could theoretically be on a slope of some kind, and the depth of the footing is lower than some part of the yard, and they could run this pipe out laterally with a slope to it, and it could have like a little bubbler or something like that, or it could go into the gutter, or this could be connected to the sewer, or it could be connected to a mechanical drainage system where and it says an approved drainage system. So the last ones I remember dealing with were in Farmington, Utah, and so those in the homes were they were mechanical. It went to a sump pump and then it pumped it out, and so it went to a drainage ditch in the backyard. So I think there's lots of different ways that the municipalities deal with groundwater around the house, but that some options right there. So sequence of construction is pretty basic, right? We've got a footing, foundation. Before we backfill, we've got to get this waterproofing all on. We've got to get the drainage mat on. First thing down, we put. Now, some people don't put the Mirify down below. I think that this is a better diagram for really what, whoops, I would like to see Mirify wrap that, or the fabric wrap the entire thing. So put the fabric down, put some gravel down to here, put the pipe in. Uh, so the fabric would be like hanging up over here on the excavation, kind of like up that way. Let's see if I can draw that. So the Mirify fabric might go like this and then up the excavation and just be sitting there. And then all this gravel gets pushed into here. Or sorry, it would go to this level, then the pipe gets put on, and then it comes to the second level, and then they just fill it all up, right? Kind of use this second level to, first level to set the grade, second level to hold it in place. And then you're just backfilling away. And then let's see if I can learn how to clear this. Then the fabric, it's going to go wrap itself around, right? And then you continue to backfill. So there's some code requirements associated with the gravel size and how far away. Um, because it's not something you would necessarily remember if I told you. Just trying to tell you that it is in the IRC specific to how this is to be built. The drainage system. So not just following this specific detail, but specific code stuff. So I went shopping on Home Depot for the perforated 4-inch drain line, and this one is covered in a fabric. So don't like this detail that they gave it, or this picture they gave here, right? What's missing in this one? It's not anywhere near the footing, or maybe it is, but looks like to be it's maybe this is a shallow foundation, and that's the space down there. Organize my desktop. Perfect time for that. Yeah. So the but that's the pipe that we'd be talking about. But this picture is not for a foundation, and I really dislike how there's like dirt mixing in with the gravel. The point of the mirified fabric is to make it so that the fines in the dirt or the soil don't come in and fill the voids in the gravel, and then you'll have settling in the soil because the soil's fine particles are mixing in with the gravel, and that's done through the movement of water, right? So the as the water moves around, um, but there's different connectors and stuff for this type of thing. So, anyways, if you're unfamiliar with what it looked like, that's what it looked like. You can this case, I think if we were doing that, wouldn't want the filter on the outside. We just want the pipe, uh, and then put the filter fabric on the outside. In my opinion, outside of the gravel. So I found another little video that I thought was worthwhile. Water percolating in to the foundation drain. Water's going, and we've got a trap, and then we're getting into the sewer. So that's one idea here. In my opinion, that's like one thing wrong with this is, do you see how the elevations here are the same? Theoretically, if this was the case, you could get sewer coming down here and then landing into this if this was dry. That's not ideal. This needs to be up higher if we're going to do it, and needs to come in at a much higher angle than at the flow line elevation of the sewer. Not a big deal, but you get an idea that that's what we're talking about there. So here's another one we got found here on YouTube, all thanks to Milwaukee Metropolitan Sewer District. And this one, it's going to a sump pump, right? So the foundation drain collects water going to a sump pump. Pump is going to be on a float switch, and so it's going to pump it out somewhere else. So an approved location where it's going to pump it out to, right? Well, the next thing we want to talk about is we just talked about keeping the water out of the building, um, out of a home, but the same thing applies in construction. And you see from this excavation photo that you see the groundwater start to accumulate as the excavation went down. And so if this water is, say, it fluctuates, the elevation of the water fluctuates, and uh, depending on how much runoff there is uh, in the winter, how much rain there is in the spring, and then even a big storm can change the water table, whether it be a foot or two. But you can kind of see in this picture the clay where the soil changes somewhere around right here. And once you get into the clays, usually that you see some water being retained. And the water doesn't move very quickly in the clay, but it does accumulate over time. So if we were to try and build something or do any footings, and I'll show you more photos here in a second, we need to dewater this area first for construction to proceed. So in this photo right here, you can kind of see that they took this big ABS pipe, and what they've done is dug a big hole. I don't know for sure in this photo what they did because I wasn't here on the project at this time, and but I can imagine what they did. They either dug a pretty good trench and lined it with mirified fabric, and they went down a little bit, and you can kind of actually you can kind of see the fab. I don't know, hard to say, but I think they either dug themselves a bit of a trench deep and lined it with mirified fabric, put gravel in it, put this put put a pipe in maybe to be able to convey it, or maybe they just dug a big pit, lined it with mirified fabric, dumped dirt in it, dumped gravel in it, put this ABS pipe in it, and the ABS pipe probably has holes down at the bottom. I'll cut in it so the water can get into this, and they can then put a pump down there, and you can see the hoses dewatering over there. Kind of see another one over here, so they probably got another dewatering pit over there. And I took this photo from Wikipedia where this is meant to show like the water table. When you start dewatering a location, then this is like a well or something like that in Wikipedia, I think is what it's meant to be. But think of this dewatering, temporary dewatering point as kind of like a well. Dig a hole, put a bunch of gravel there, water starts coming into that gravel, and you start pumping it out. Well, what it does to the water table is it starts to do this. It's like if you're standing on a big trampoline and you think of the water table being like the surface of the trampoline, if you stand in the middle, it starts to remove water, not horizontally straight across, but it starts to remove water like at an angle up like this. And that and I don't understand all the physics of it, but like the characteristics of water and seeing how like you put water in a napkin, it can climb up the napkin. It's the same kind of stuff, physics is that, but I'm not a physics professor or anything like that. So I just understand basically that that's what I think it's called surface tension of water or something like that. The but in order to so once if they've dug this deep enough right here and say it's collecting dewatering like this entire area kind of like at an angle like you see in this, so like this angle here is coming off and maybe coming way over here, you can dewater large areas with just a single pit. Or if they did a trench along here or some other direction, it would look the same thing, other than it would have like a bunch of, uh, instead of having a single point, it would kind of come off at an angle in a row. But we've got a couple things to consider when you're dewatering. One, creating a plan, somebody that knows what they're doing, whether it's the civil engineer in concert with the excavation contractor, but also getting the permits, going through that process. So putting the plan together and getting the permit on a large project like this to try and dewater, and then deciding how far down do we need to lower the water table. I was talking about um, that Bear River Bird Refuge project. The If my memory is right, we had probably 4 feet down below the bottom of the footing was the piping to dewater that building, and it was only for construction. The dewatering was only to allow construction to move forward. It was not a permanent dewatering system. So we dug a series of trenches underneath the entire building, lined them with mirified fabric, put gravel in them. All those trenches underneath the building, I think they're like every 15 feet or something like that. They're width of a track hoe bucket, so maybe 2.5 feet, something like that. And they ran the course of the building. They all collected on the west side, and then on the west side, it was something like this, where you had a buried ABS pipe, and then we pumped that. And when the next part is like, where are you going to discharge that water? So is it going into a storm drain? Is it going into something else? And so sometimes you have to let the water clear up a little bit before you can get it into a storm drain. So you have to have like a settling pond, almost like a temporary storage location for the water, so that the fines can settle out, and then slowly get over to the storm drain. So what we did we had to do the same thing in Bear River Bird Refuge. We had a pretty good settling pond that we built, probably half the size of someone's swimming pool uh, in their backyard, maybe not nearly as deep, maybe a couple feet deep. But we dewatered into that, let the water settle, and then it had like this weir on one end of it, so that the water kind of went over this weir and into the Bear River drainage area. So lots of things to consider as far as like how it could be done. Putting a good plan together for a dewatering system like this matters. The logistics of pumps, power, the hoses, all that kind of stuff, whether it's going to be ABS or PVC hoses or all the connections, there's a lot to it. You can kind of see in the far end of this picture, like how many pipes there are, how many temporary hoses there are, and then inevitably your hoses get damaged, and inevitably the pumps go bad. So they get to have spares. Let's move on past the temporary and get into the actual dewatering of a building. So as you see the excavations start to go down, you don't see any water right now. And on the far side right here, you can see the shoring continue to go down. And so the piles over here, they haven't added more to it, but they will be. So they're starting to go down. They get down to a part, you can see that they've put in their dewatering system, temporary dewatering system. We're down to the lowest part of the building right here in this area. And so the first thing that this building is going to get a bunch of gravel, and then a concrete floor, a big concrete mat footing. It's going to act as the floor as well, a garage basement. And so you can see the mirified between the two, and then you can see a bunch of gravel, and then the concrete's going to be on top of that. But as is always, deepest to shallow is not that might not be the deepest. In different areas, they'll be digging it out, and then we've got to go down even farther for uh, more sewer piping, or garage collection drains, area drains for the garage, depending on what these are. So the dewatering system here, the temporary one that's in place, is helping this get to a point where it's even workable. You can see that they're backfilling not with gravel; they're backfilling. It looks like with some native materials to me. So let's. But you can see the construction sequence. They've been working in this photo uh, from the right going to the left, and you can see that the work progressing and getting to a point where they can now backfill this, bring it up, and bring the mirified over, and bring the gravel over, and they'll continue to stage. You can see that a little bit better in another photo here. That's a good photo right there. This one's a good example where you got the completed work on the right, oh, excuse me, on the left, mirified fabric, and then in this one, they're starting to put down the actual uh, dewatering system. All right, I hope this helps. I brought that photo from the PowerPoint in, and in the purple, we've got the garage basement. And the yellow, this drawing was produced by the civil engineer, and it's showing the building's permanent dewatering system, not the temporary for construction purposes, but the permanent one. And so what we're seeing here in the yellow is the piping. So it's an 8-inch. The invert elevation is 4,216.44 feet above sea level. Invert elevation basically means the flow line of the pipe. Um, and so when you look at that trench right here, we're probably looking at something like one of these ones and one of that. Kind of see how this one over here comes over, and then can barely see it coming through here, and the other one coming over here. But that one right there might be, for instance, this one, and then this one right here is that one. And they're going to put all the perforated pipe in the ground. They're just putting down the bedding layer now, setting the grade so that the slope is something that the pipe can drain towards this center one. Right over here is going to be the same thing. They're going to fill it up with a little bit of gravel to set the grade, and then they'll put the pipe in, set it to grade, connect it all. Got all the perforation pipe. So you can kind of see here the elevation. Just kind of pay attention to the last two numbers. We know it's 4,200 feet above sea level, but 18.78 feet, and this is 16.24. So this is definitely lower in elevation than this point. So the pipe is sloping this way, and it's going to collect in this one here. So they're telling you that it's a 25% slope right there. Or excuse me, not 25%, 0.25. It's a quarter or 5/16 per foot is basically what that is, a slope. And so all these pipes and trenches collect in this trench and in this one here and come all the way over to this sump pit right here. And we'll have to pick that up with the plumbing. Let's see what above slab. Yeah, let's do the below slab one. Okay, here's the plumbing below slab. So maybe I should split screen this a little bit, help you. And what do you know? They're rotated differently, so I don't know. We'll do that anyway. Okay. That was maybe a bad idea, but whatever. I mean, it is what it is. I was trying to make it easy. So you have the main trunk coming down, and it collects into this sump pit right here. And the sump pit is basically like a storm drain or a sewer, uh, a sewer. It's a series of precast, usually like 48-inch precast pipe set on top of each other. Anyway, there's a pit right here, a collection drain location, a collection location for all the water. So the water's coming in here, gonna land in this pit. The water from this side's coming down this trench over here and then going in. So the invert elevation here, that means invert in is on the south 42, 17, 18. So that's the flow line of the pipe. So if you think of the pipe and the inside of the pipe, we'll over communicate a little bit here. That's our pipe. The flow line is where my mouse is right there. That's also the invert elevation. That's I don't know why they could do IE, but so pipes coming into this sump over here, pipes coming into the sump here, collects here, and now the civil turns it over to the plumbing to take care of. So now we have to go to the plumbing drawings. Okay, we've got this sump pit right here. So let me get rid of this one and go to, here's our above grade one. Okay, so this is the below grade piping. They're not showing the civil piping because this is the plumbing piping, right? So in the plumbing, they have a 2-inch vent off that coming up right here. And then we've got an underground SD, so they're calling it SD storm drain, basically. A 3-inch storm drain, and then it comes up on this column right here. Kind of get oriented. This is below grade plumbing. That's a garage drain right there. And this is some plumbing catching the garage drain up above. But this is the one, oh, sorry, this is a garage drain down below too. Not sure why. Oh, it must be a vent. Nope. SOW, soil something. I can't remember what that's called. Oil water? I can't remember. Sand oil water. So this is a separate drain. But yeah, this would be picking up something up above, I assume, and then it's coming into this line. Same thing with this, but this is a garage drain. This one's coming from the floor line over. I'm not sure why this one's, oh yeah, because it's under the slab. My bad. I got caught up on that one. I apologize. I had to start thinking through it. But we were wanting to talk about the sump pit. We got 2 pumps in here. They're pumping the water to here. And then it goes up and it hits onto the bottom of the ceiling above. And this pipe's suspended from the ceiling above. And it's coming right there. So this one and that point are the same. I'll point at them. Whoops. That point and that point. This is just what's above this side. The right-hand side's below slab. The left-hand side is above the slab and actually in the ceiling. And so the not in the ceiling, but on the bottom side of the parking garage is next floor. So this pipe is suspended and it's coming over here and it ties into this storm drain here and comes over to here. And what do you think this note number 4 will say? Probably says connect to this civil. Yep, 6-inch storm drain. Out. They have to bring it outside the building 5 feet and continuation by civil. Now this is one of the ones that studying this out a little bit. If I made things more complicated, because they always end up being complicated, even something simple like this. So I'll bring the civil back up. Utility plan. I'll zoom in. All right. Now, the yellow is the storm drain. The green is sewer or oil water. So let's look at how they're coming out of the building. Where you kind of have to use your spatial skills to align this. But you can see the elevator pit right here. There's the elevator pit. So we're looking at that. Whoops, I keep doing that. That elevator pit. Try and align it with, I just barely did that. Can't think and draw at the same time. All right. Align these 2 points in your mind, that elevator with this. And you think, okay, just south of the elevator, we've got this FM, and then we've got this other line right there. And then we've got the green. So this, looking at it right here, and let's just keep following it down. So we go 1, 2, 3, 4, 5 things coming out of the building from this side of the elevator shaft. So 1, 2, 3, 4. Where's the 5th one? They don't have a 5th one out for some reason. So let's just start figuring out what they are. Okay, from the bottom up, we got a sanitary sewer. That's green. That makes sense. That aligns with this one coming out of the building. Then we've got orange. That's storm drain, and they even labeled it storm drain coming out of the building right here. There's the storm drain right there. And then we've got grease waste and the grease interceptor box. So we know what that one is. That's the greased waste. And then for some reason we have one storm drain, but we have two storm drains for the civil thinking. But look at what this one right here. Do you see that little circle right there? It says storm drain up. That's collecting a garage drain up above, and so that would be water, basically storm drain, and they're bringing it out. But they want the forced, but the civil, they have this one right here called the forced main, not this one. This is gravity fed. This one's forced. So this one's the one that is going to be under pressure. At least the civil designer says we want the forced main, the one under pressure, the one that's going to be pushing water from a pump, to be separate from this storm drain one, because one of them comes right into a collection box and the other one goes into this infiltration system. So they want the one that's just going to trickle slowly to go here, and the one that's going to be pushing a lot of water to not hit this infiltration box and go hit that storm drain back out to the main city storm. So when you're looking at this stuff, it's a good example of the two disciplines not being fully coordinated. And it can take some time when you're trying to figure out what's going on in this area when the two different disciplines haven't coordinated well. But that's the system from let's go back just a little bit. Not that one. So thinking through this a little bit, they're digging out in the underneath the footing foundation. They're digging trenches, putting the Mirify fabric in, put the pipe in. The gravel slope, so the pipe's going to follow that slope when they put it together. They're going to bury it and they put more gravel over. That is these pipes right here that they're putting in. The pipe is going all the way down to this sump pit. The sump pit's somewhere over here in the basement. Then if we follow the plumbing drawings, which we were just sort of looking at, the plumbing drawings are taking it, and they don't have it drawn correctly. It should come out of this point right here. And it should come out separate, like over here like that, and tie into this forced main right here and come over to here. So I'm hoping you find this interesting. We're switching back and forth between civil and plumbing to try and understand how the system is draining underneath the building. But at some point in time, well, before we go to that, let me go back to PowerPoint and we'll look at the rest of the pictures for how it gets constructed. Okay, we're back to that same photo we were looking at, and you can see, in my opinion, a really nice construction sequence. You can see that they left the dirt up high. You can almost tell that this is like ramped from the photo. So they've made themselves, before they've excavated down all this dirt and got into a dewatering position where they have to dewater, they're putting in the dewatering system. You can kind of see like there being a hose. I don't know if this one's one, but you can see it right over here too. So they're using the permanent dewatering system. You can see another one right here coming out. They're starting to use the permanent dewatering system to keep the water out. And so they probably have some temporary ones, but they're starting to switch over to use the permanent one as their temporary, I guess, because they're just hooking up hoses to these parts where the water's starting to seep in through this pipe. Because there's a pipe coming right down here, right? And it's going to have some water in it. So they've got a pump right here, and they're pumping the water out. And then they're working on this section. They'll go excavate some more. Let's see if I got the same kind of thing. Okay, so before they've excavated somewhere, they're bringing gravel over, filling up over the top. They've got their pipe in. It was a hose. You can see that they've got another hose temporary pump down over here, pumping it out. They'll dig this some more. Oh, I did this slide. Sorry, just an up close version of what it looks like, right? Um, I want to go back here. They're gonna get to a point where if they're comfortable with this, they'll start to remove this dirt, and then they'll do another section of piping, the low grade. Uh, so, and then, right, so you follow that. So they'll dig this out. Right next to it is a dewatering line that will be collecting water, and that way they can then do some more stuff deepest to shallow, which is below them. So they've now done more plumbing to get to that point, excavate it out, go down, do some more, then do another section of this, bring the gravel over like you see in this photo, start to bury it, then they'll dig more, let the plumber go, put in another trench like this. It's just this process of moving dirt down to grade, getting the plumber in there, then doing a trench for the dewatering system, putting in the Mirify fabric, putting in the gravel to slope that pipe the right way, and then putting the pipe in more gravel, and then burying it with gravel. And in this photo, you can kind of see people then falling back behind that team doing piping that is more on the surface. So deepest to shallow, it went in deep. And then they put in the gravel. Now they're moving some gravel away so they can finish off the rest of this piping. And I just talked about that one. We've talked about it a lot. Sloping pipe and in gravel surrounded by my fabric, right? And then you see people like this being on the surface of the gravel. So electricians wanting to be right at the top of the gravel. They don't have to deal with the water at all, but you can kind of see the construction sequence that is going on, and this is done by a good superintendent. This whole sequence here with a good excavator and plumbing and electricians are all working well. So they've done a really nice job of sequencing themselves from one side of the project to the other and dealing with the water. So then starting back where they've already finished, starting to put in the rebar. So one of the things I wanted to talk about was as they go over to the permanent dewatering system, uh, they've got these depressed areas for maybe thickened footings or something like that, or maybe this is the elevator pit, probably an elevator pit. But the dewatering system's not below that level, the bottom of the elevator pit, so they'll probably have to pump this out. Um, but you can see that it's starting to collect water. The water table in this area right here, maybe there's not a drain pipe close enough. Remember that picture of the so we have a drain right there, and remember how I was saying like it would look like that, the water. Oh, that was terrible. Uh, from the when you pump out water is what I was trying to say. When you pump out water, if you remember the topic about standing on a trampoline, well, say the pipe is like that. I wonder why that keeps doing that. Anyway, it might not be deep enough. As we go back to that photo of where that pipe is, it's near the top of the Mirify fabric. So once they start burying the permanent, the pipe, because it was at different elevations, the farther to the one side of the building this pipe has to get higher. It means that the water table isn't really getting lowered evenly in all locations because the pipe is sloping. So they've picked an elevation they think is economical and will work for the permanent building. But obviously, when you're using the permanent system, there is problems there when it doesn't get low enough for construction in all locations. That's not what I wanted to do. Okay, erase. There we go. Sorry about my discard that. There we go. Oh, back to PowerPoint. But I'm really having trouble with today. All right, going back. Let me see if I have any more. You can see another one right here. The dewatering system is done for the building. They're using it, but it's not deep enough for that elevator pit. You can see the depressed areas for the footings that are deeper. Okay, end of slideshow. So from from this lecture, I was really hoping you get a feel for. Let me end it on my first experience dealing with the Bear River Bird Refuge. So this had a complicated dewatering system for construction. There wasn't the dewatering system in the building was a series of area drains in the basement. If water got into the basement, the sloped floor went to all these individual sumps, and they were fine with having a little bit of water on the floor, and goes to like these 20 or so different sumps around the building, just little 1 foot depressed areas, so they can put sumps in there, and they're on a float, and piping that's piping it, so that this building has a bunch of little pumps all around. But I remember a couple things that I was really surprised about, and let me share the experience. So one was we were doing construction, and the pump that we had dewatering the system, it ended up getting really corroded because this is kind of like salt marsh almost, and so the pump just got eaten up. It was brand new when we bought it. I remember pulling it out of the that riser, the temporary riser, and it looked like it was 70 years old. It was all corroded and rusted, and it died one day. And we're like, oh man, what's going on? Anyways, the groundwater came up pretty dang quick. And I don't remember what phase of construction we were in. It seems like we had most of the foundation backfilled and some of it not. And so we started to see the water table start to rise. Quickly got a new pump in there, but I think the lesson learned there for me was, man, always have extra pumps. If you're doing dewatering, you need to have more than one pump that works. A good reliable electrical source is another thing. Running off of a generator isn't ideal, because then you maybe run out of fuel over the weekend or something like that, or forget to fuel it, and then you're back in the same boat. But anyways, making sure that your dewatering pumps can work at all times, that's a really good thing to pay attention to. The other thing I wanted to share was, remember when we switched off our dewatering system is toward the end of the project, and remember this building, it doesn't have the trenches down below the building, and the gravel and the piping was all for construction so that we could keep this area dry during construction. It was time to start filling up these ponds, and they wanted that dewatering system off so that the groundwater would come back, and then these ponds would start to fill up. Well, I remember having that switched off, and there's a riser for the sprinkler pipe down in the basement, and you can't cast concrete around your riser. So I don't know why, but maybe you can by code, but for some reason we don't. Maybe it's a code thing that you can't, but it seems like my memory says that you can't do that. So there was a hole in the footing, in the mat footing, about a foot diameter, and the sprinkler pipe was coming up through that. And so for the fire suppression system. And about a couple days after we turned the dewatering system on, came back, and there was like a mini geyser in the basement around that sprinkler pipe. There was a lot of water, and I'm talking like a little geyser shooting up about, I don't know, 8 inches. I don't think that's an exaggeration at all. That it was 8-inch geyser, and the basement was just flooding galore. So it was just, and we were trying to switch over to the permanent, but there was just so much water coming in through that fire sprinkler. Anyways, it was interesting that when you switch over to the permanent one, it's not as deep as the one you want for construction, and so that water table starts to come up, and then you're dealing with another problem, right? And anyways, it was a day to remember, sloshing through there, getting all the pumps that we had operational and pumping out the basement, and then figuring out how we're gonna seal that seal that. Anyway, I think the first thing we did was go switch back on our dewatering system, brought the water table down, pumped out the basement, figured out what we were going to do with that hole in the around the or anyway around that fire sprinkler pipe riser. But it was interesting, and I don't remember anyone ever really talking about dewatering systems in my courses in college that when I was going through. So I thought, hey, I'm going to do this lecture. It was one of the first things I dealt with when I was first in management. Had to learn a lot about it at that time, and been on many projects with the dewatering system that uh, there's lots of problems when they fail and you don't have a backup plan or the power goes out for long periods of time. It can be a real challenge. So thinking through those logistical things of your fail safes and what's going to happen when your water table starts coming back up at different times can be a real fun thing to deal with. Hope you enjoyed the lecture, and we'll catch you in the next one.